doesn't work, I'll get something else worked out. But anyway, your second test is on Thursday. Covers two chapters, chapter 5 and chapter 8. I'm going to be out of town. I'm leaving tomorrow morning early, so another professor is going to proctor your test, another finance professor. So if you have questions, he can answer your questions. And I will be back next Tuesday, okay? Also, a reminder that next week is our Money Smart week. So we're going to be having programs Monday, Tuesday, Wednesday, and Thursday afternoon at 4 o'clock. Most of them are going to be in Mason Hall, which is in the nursing building, the Mason Hall Auditorium. One afternoon, and it's either Tuesday or Wednesday. They're kind of changing it up on me. One afternoon is going to be in the Curris Center, okay? Now, you may be asking yourself, why would I want to go to a program at 4 o'clock? Well, we're going to be talking about a lot of different personal finance information. So some really good information that a lot of you could probably benefit from, or a lot of your friends could probably benefit from. So I'm asking you if you would tell somebody, tell your friends in your fraternities, your sororities, your residential colleges, just people that you know, because keep in mind, you're the business people, okay? You have a better understanding than anybody on campus of this information. So think about your friends in other areas. Try to get them to show up. We want as many people as possible to show up. And to do that, we've got some really good prizes or gifts that we're going to give away during the 4 days. A couple that I just got information on this morning is 2 St. Louis Cardinals tickets. I think it said they were for April 17th, which is a Monday. They're really good tickets. They're $159 tickets, and we'll be giving those away one day. We'll be drawing names for that, and we'll have some other, we'll find out today at our meeting at 2 o'clock what the other door prizes are, but we have some really, really good giveaways, including 2 $500 scholarships for undergraduate students. So it's $500 for doing nothing other than showing up, okay, and having your name drawn. So, again, I'll remind you about that. I'll probably send out an email or something while I'm out of town. But please, please try to show up, try to bring people if possible. If you need some extra points, then there's some extra points. Those of you who need some extra point opportunities. And we really want a good turnout for this. I'm going to be talking either on Tuesday or Wednesday afternoon. Again, I should know that today. But are there any questions about any of that? When? It's going to be Monday, Tuesday, Wednesday, and Thursday afternoon. So it's going to be all week. And each one's at 4 o'clock, 4 to 5. So pretty quick, pretty painless, good information. And we spend a lot of time, or a lot of students especially spend a lot of time planning this, putting this together. So what the hell is this thing? They know what that is? Because I don't. No? Okay. Well, let me point out a couple of things with my strange pointer here. Okay, so test number 2. If you go down to the testing items on your Canvas homepage, if you move on down here, you're going to see, which we're going to cover today, some Chapter 5 and Chapter 8 practice questions. You will then see the solutions to these. So I just basically, what I did, I went through where I worked these by hand with the calculator inputs and all of the calculations, and I just scanned these and posted them here. Okay, so it's going to be the same thing that we go over in class today. But I did want to be able to answer any questions that you might have. Also, these are just the answers. I had that at first, and then I added this, so I just left that there. Your study guide for test 2, the Chapter 5 formula sheet, which will be given to you on the test, and the Chapter 8 formula sheet, which will be given to you on the test. The test is the same as the first test, 50 multiple choice questions. You will have an answer sheet. It's going to be, it's a combination, just like the first test, of calculations and theory, definition type questions. Now, a lot of people, they see this and they see all the calculations in chapter 5 and they see quite a few of the calculations in chapter 8. And when you start studying, you're thinking, man, this is going to be all calculations. It's going to be all financial calculator, okay? It's not going to be that way. It's split about probably 40% definitions and definitions in theory. No, 60% definition theory, 40% calculations, okay? Around there somewhere. So you need to read the chapters. You need to look at your slides. You need to work through as many problems as possible. You need to take a close look at the practice problems and questions we're going to discuss in class today. Let me say that again. You need to take a close look at the 33 practice questions and problems that we're going to talk about in class today. Do I need to say it? I don't need to say it again. No, you get the idea? You get the point? Because you may see some of these, you may see several of these on Thursday. All right, so questions about, I think we've got our technical issues worked out. Are there any questions about the test, the semester? Now we've got advising coming up and we've got registration coming up, so if any of you need to talk to me about anything advising-wise, then let's set up an appointment next week, Tuesday, Wednesday, Thursday, whatever, and I'll be happy to talk to you. Are there any? Yeah, you will get this let's see, this exact formula sheet. So this is chapter 5. So it's going to look just like this. Now, most of these you're not going to need. You know, this is the present value of a lump sum, present value of an annuity, present value of perpetuity. This one might come in handy, actually. Future value, the effective annual rate. I mean, this is basically calculator calculations, but if you forget something, you might go to the formula sheet and take a look. You can also go to the chapter 8 formula sheet. This one's going to be also included just like you see it here. So this is your return formula, percentage return. This is the expected rate of return, standard deviation, portfolio return, coefficient variation, portfolio beta, and the percentage weight of a stock. So I think those are the only formulas that we covered in chapter 5 and chapter 8. Okay, good question. Other questions before we jump into some of the questions and problems? All right, then if not, let's see, I'm kind of torn between, do I want to do this or do I want to make my life a little easier and do this? Okay, so you can see. Okay, why don't we just, which one of those do you want to look at? You want to look at the ones where it's already there? Do you want to look at the blank one and we can work through the problems? This may give you a little more chance to write down the inputs instead of me just pulling up the calculator and doing it. Tell you what, let's do this. If you want me to work through any of these, I can do that, okay? But let's just take a look at some of the questions. I would just want to make sure that you understand sort of the reason behind why I selected some of these questions. These are from the same test bank that your test comes from. The wording sometimes, as you noticed in test 1, the wording is sometimes a little tricky for students. I tried to catch that as much as possible and change the wording around to make it a little bit easier to understand. Sometimes these kind of just slip through and I don't see it, okay, but hopefully this will make some sense to you. By the way, here's one additional calculator if somebody needs one. And actually, I think somebody borrowed another one of my calculators, so that's fine. You can hang on to it. Just be sure to, like next Tuesday or whatever, be sure to bring it back so I can have it for other students to use. All right, so chapter 5, time value of money. We spent a lot of time in this chapter. I said it's the most important chapter that we're going to cover all semester. I mean, you have to understand time value of money if you want to understand the other parts of finance. For example, stock valuation, bond valuation, the capital budgeting section that we will get to. And so I've got several questions. I think the first 16 questions, yes, the first 16 questions cover chapter 5, and questions 17 through 33 cover chapter 8. So here is the first question. It says, in future value or present value problems, unless stated otherwise, cash flows are assumed to be or are assumed to occur when? And we said, if it doesn't mention it, we're assuming the cash flows occur at the end of each period. The end of the week, the end of the month, the end of the year, whatever the situation may be. Number 2, we talked about the future value interest factor. That was in the formula, that is the 1 plus r raised to the nth power. So it says the future value interest factor is, and I guess to be technically correct, this should say always greater than 1 if the interest rate is greater than 0. Okay? Somebody could be, you could say, hey, what if you had a 0% interest rate? Then it's going to equal 1.0. Or what if you had a negative interest rate? It's going to be less than 1.0. But since you've all seen this problem the way it's written, none of those excuses are going to work. Okay? So if you happen to see this question on the test, you know that the future value interest factor is always greater than 1. Because, and again, think about when we calculated this, when you have a present value and you're calculating a future value, the future value is always going to be larger than your starting present value. And if it's not, you need to take another look at your calculations. All right, the future value of, actually I didn't work this one, $100 received today, deposited at 6% for 4 years is. Now this one, let me bring up, let's see, 160. This is one of the ones that I did not work, so let me, try to make this, wow, okay. We don't want that, we want something else. We want this one, all right. So this is just a basic future value of lump sum problem. So we have the present value of 100. How many years was that? 4 and 6%. Supposed to be a lot. Well, first of all, when you're looking at this, and if you're looking at the possible answers, I think of the 3 answers, one of them was less than $100. So that's an answer that you can just take out immediately. Okay, it's not a possibility because the future value has to be larger than the present value. And if we enter this information, bring up our calculator. Now, I want to check a couple of things because, again, when you're practicing with this, you're not really sure where you left off when you finished studying for the test. So when you take the test, you always want to set, make sure that your payments per year, if I press my second key, you want to make sure that your payments per year are set on 1. So I'm good. If yours is not set on 1, press the number 1 and press the enter key to lock it in. Now I'm going to press my clear button, and then I want to go through the clear process. So I'm going to press my second clear time value of money, second clear work. All right, so now I'm ready to work the problem, and we said we had 100 was my present value, 4 was my in, and 6 was the interest per year, I/Y. And I want to compute the future value. So this tells me that the answer should be $126, and I think they rounded down, so just to an even 126. Now, one thing about this particular question, and so let me show it to you so you can see it. One thing that I've tried to change on the test, these two answers are pretty close, okay, 126 and 124. What I've tried to do on the test is make sure that the answers are, there's enough difference that you're not going to, get some answer like 125 something and try to figure out, wait a minute, is it 126? Is it 124? So I've tried to go through and do that. So what I'm saying is you shouldn't probably see one this close in terms of answers on the test, unless you happen to see this one and then you know the answer is 126. Okay, so did everybody come up with the right answer to that question? Basic time value. Okay. Number 4, the interest rate. If the interest rate is 0, the value interest factor equals, and that would be 1.0. Okay. And again, what I'm talking about here is this part where I have the formula where the present value is equal to the future value is equal to the present value times 1 plus r raised to the nth power. This is the future value interest factor. So basically what this is saying is if we have 1 plus 0% interest raised to any power, what is 1 raised to the 1 plus 0 raised to the first power? It's going to equal 1. What is 1 raised to the 98th power? It's going to be 1. Okay, so that's what this is referring to. All right, number 5, the value of $100 to be received 10 years from today, assuming an opportunity cost of 9% is. This is one of the questions that tends to, when people read this, they're like, what are they asking for? So if you take a look at it, it's asking you, what is the present value of $100 that you're going to receive in 10 years? What's it worth today? So you can see the answers, or the inputs for your calculator. The future value is going to be 100. We're going to receive that $100 in 10 years. And our opportunity cost, or our discount rate for this particular problem, is 9%. We want to compute the present value. And again, just understanding the concept of time value of money. If you're looking at this particular problem, we can take out 2 answers automatically. Which 2 can we ignore? A and B. That's exactly right, because the present value has to be less than the future value that you're going to receive. So it has to be less than $100. So if I don't even have a financial calculator, I can narrow this down to a 50-50 shot. It's either going to be answer C or answer D. And when you work through it, you're going to come out with a present value of $42.24. Now, what I'm going to do is I'll let you work through these on your own. But if you're not getting the right answer, let me know and I will bring up my calculator and go through it. Okay? So I just want to make sure everybody is comfortable calculating these. Number 6, the amount of money that would have to be invested today at a given interest rate over a specified period in order to equal a future amount is called what? That is the present value. All right. Number 7. I thought I'd worked all these. Apparently I didn't. The present value of $200 to be received 10 years from today, assuming an opportunity cost of 10% is. So again, this is another present value calculation. So 200 is the future value, 10 is your N, and 10% is your I/Y, your interest per year. So again, if I'm looking at this, I can omit 2 answers automatically. That would be answer B and answer C. Those aren't possibilities because the present value has to be less than the $200 future value. And if I enter this information into my financial calculator, okay, so I'm here. I want to go through and clear everything out. I would put in 200 as my future value, 10 as my in, and 10 as the interest per year, and compute the present value. And it comes up to $77. All right, so everybody good with these? Pretty simple questions, pretty easy questions so far. All right. Number 8, the future value of a dollar blank as the interest rate increases and blank the farther into the future an initial deposit is to be received. Okay, this one's not really that difficult. You just have to take some time to read through it carefully. So it makes the most sense if it says, answer C, the future value of a dollar increases as the interest rate increases, and that makes sense. As we earn more and more interest, the future value is going to get larger, and it increases the farther into the future an initial deposit is to be received. So that's simply saying the longer you have it invested, the larger the future value. It just doesn't say it in those simple terms. So everybody okay with number 8? Makes sense? All right, number 9, the annual rate of return is variously referred to as, and we call it all of these. Sometimes I call it the discount rate, the opportunity cost, the interest rate, the cost of capital, the required return. I mean, there's lots of different names that we use, so all of those would work. An annuity with an infinite life is called a perpetuity. That's a perpetual annuity. So again, that's an annuity that lasts forever. And we went through the example of if you want to create a scholarship at a university, then you would donate a lump sum of cash, and they're going to take the earnings from that cash that when they invest it, and that's going to fund the scholarships forever. All right, number 11, the present value of a $20,000 perpetuity at a 7% discount rate is, now this is one of the formulas that you will have on your formula sheet. This doesn't involve a financial calculator. We simply take the cash flow that we want to receive for, which in this case is the $20,000, divided by the rate of return we can earn on our money. So 20,000 divided by 7 equals 285,714. Now again, keep in mind what we're doing here. If we invest $285,714.29 into an account earning 7% interest, it's going to earn $20,000 of interest per year. So what we're doing is we're taking the interest that's created, we can spend that, but we're not touching this principal amount that we've invested. So as long as the 7%, we can earn 7%, we're going to keep on earning $20,000 per year, at least theoretically, forever. All right, number 12. Dan plans to fund his individual retirement account with a maximum contribution of $2,000 at the end of each year for the next 10 years. Now again, keep in mind as you're reading through this, there are some important points here. First of all, it says he's going to be making the deposits at the end of each year. So this is an ordinary annuity. If Dan can earn 10% on his contributions, how much will he have at the end of the 10th year? We went through an example similar to this in class, but we had monthly contributions, okay? This is an annual contribution, so your calculator should still be set on one payment per year. As you enter the information, this is the future value of an annuity, so the payment is $2,000. N is 10, I/Y is 10, and we want to compute the future value, which should equal $31,874. And again, if you understand the concept of time value of money, and we're looking at this, we're thinking, okay, this is a future value. He is putting in $2,000 per year times 10 years. He's putting in $20,000. So the answer has to be larger than $20,000. So as we're looking at this, B is not an option. A is not an option. So again, we've got it narrowed down to a 50% chance of getting it correct. So I guess what I'm saying is if you get on some of these problems, if something's just not working, use your understanding of the concepts to help you narrow it down. Because I'd much rather have a 50% chance if I've got to guess at this problem than a 25% chance. All right, number 13. You've been offered a project paying $300 at the beginning of each year. So there's the key word, beginning. For the next 20 years. What is the maximum amount of money you would invest in this project if you expect a 9% rate of return on your investment? Now, this is another one of those questions where it helps to understand, what is this asking for? What it's saying is, if you're going to receive $300 at the beginning of each year for 20 years, and you require a 9% rate of return on your investment, how much are you willing to pay today to receive that $300 per year for the next 20 years? So this is a present value of an annuity due problem. Okay, so notice we're changing to beginning of period of payments here. So you would go through that process, and let me bring this up and go through that with you. Okay, so to change to beginning of period payments, we're going to use right above the payment key, you see the letters BGN, second payment. We're currently set to end of period payments. That's where we want to be most of the time. But you'll notice the set key is the toggle switch to go back and forth. So we're going to press the second key, and the set key is right above the enter key. Now, if we press our clear button, you'll notice the letters BGN at the top of the screen. That's to remind us we've changed to beginning of period payments. And before we work another problem, we need to change back using the exact same keystrokes. So once we're here, we can put in our, let's see, I don't know if I cleared everything out, so just to make sure. Our 300, which is our payment. 20 is our in, and 9 is the interest per year. And we want to compute, in this case, the present value. So this says you would pay $2,985 today, and it's going to provide you with $300 per year for the next 20 years and a 9% return on your money. Did everybody get that right? No? Okay, if you would, press your second button and then the I/Y. Should say 1. Yeah, so put it on 1 and then press the enter key. Top. Now if you clear it out and go through the process, and you can check it with this one if you want to, or some of the others, you should get the right answer. All right, anybody else? Now's the time for us to figure this out, not on Thursday. $2,007. Yeah, that difference. Yeah, if you see a difference like that, for example, I mean, it's hard to tell because it depends on the inputs, but if you see just a small difference between what the answer is and what you're getting, probably you haven't changed to either beginning or end of period payments, because there will be a slight difference. Now, if you're getting something crazy like 27 million as an answer, then you're doing something else wrong, okay? But if that was a really good example of how you can a lot of times tell if you're doing something very small wrong. All right, now I'm going to change this back. So I'm going to press my second payment, second enter, and I'm back to end of period payments. And you'll notice the letters BGN are gone from the top of my screen. All right, let's see. We have a mixed stream of cash flows. The present value of $1,000 received at the end of year 1, $1,200 at the end of year 2, and $1,300 at the end of year 3, assuming an opportunity cost of 7% is. Okay, so I just drew a timeline here. Okay, you don't have to, but sometimes it just makes it a little bit easier to determine when are these cash flows occurring. This is today, time period 0. So the end of the first period is here, $1,000. The end of the second period is here, $1,200. the end of the third period here. All right, now what I'm going to do, if I go to my financial calculator, you can do this a couple of different ways. One is you could simply take each of these back the appropriate number of time periods using a 7% discount rate and add them together. And that's fine, that works. But what we went through in class was we used the cash flow register, the CF key, and we entered this information as they occurred, and then we used the NPV function to calculate the present value. So in this case, once I press my cash flow key, I'm going to press the second key and the clear work key in the bottom left-hand corner. That clears out any old cash flows from previous problems that I might have worked. Now I'm going to enter the information. You'll notice at time period 0, which is what this represents, we don't have a cash flow. So we're going to use our arrows to move around within this function. I'm going to press my down arrow key one time, and then this asks for the cash flow at time period 1, which is 1,000. So I'll put in 1,000. It tells you at the top of the screen, press the enter key to lock it in. If you don't press the enter key and just down arrow past it, it's going to go to 0. This is, now I'm going to press my down arrow key again. F01, this is the frequency of cash flow 1. How many times in a row does cash flow number 1 occur? The default is always 1. That's what we want because it only occurs once. So we're just going to leave it alone. If we wanted to change it, you know, we could put in the correct number and press the enter key. Cash flow number 2, which is $1,200. So if we put in 1,200, press the enter key, and you can see kind of what we're doing here. Press the down arrow key again. 1 is correct, so I'm going to press my down arrow key and put in 1,300 and press the enter key. And if we want to, we could press the down arrow key just to take a look at our cash flow, so that's correct. Now, so what it's going to do, it's going to take you one period into the future, period 4, which is the once you cap, and it doesn't matter where you stop here, press the NPV key, the net present value. And it's going to ask for a discount rate. In this case, it is 7%. So we're just going to enter 7, press the enter key, press the down arrow key one time, and press the compute key. And so, let me get over to the answers. Okay, it should be 3,040. Actually, if we round up, it should be $3,044. Well, yes, you could calculate it like this. Okay, so we could just calculate this as the present value of 3 different lump sums. So the first one, we have the present value is equal to the 1,000 divided by 1 plus 0.07 raised to the first power, because we're just taking it back one time period, and whatever that equals. The second one is 1,200 divided by 1 plus 0.07 raised to the second power, because we're taking it back 2 time periods. And then the third one is the present value of, let's see, the 1,300 divided by 1 plus 0.07 raised to the third power. You can work through that. Do what? Yes, whatever this is, whatever this is, and whatever this is, just add them all up, and you're going to come up with the same answer. And again, I want you to go with whatever you're most comfortable with. If this is easier for you, that's fine. But if you're going to do something like this, again, I would suggest drawing the timeline, because if you take a look at the timeline, you will see that you will see here that you can just take each of these back and you can just count off the appropriate number of time periods. Is there a question? Which one are you trying to do? With the cash flows? Okay. Go back and take a look at your cash flow 3. And then the frequency of cash flow 3, I think you got it mixed up there. So put in 1300 there. And press your enter key. And then if you look at the frequency, it's got like 1500 or something. So just put 1 and press the enter key for the frequency. You haven't gotten this one or any of them? This one? 30,043. Okay, so cash flow, so 1,000. Okay. If you take a look at the frequencies, what you've done is you got that right, cash flow number 1. Your frequency should be just 1 because it just occurs one time. Okay.
I just put 1200.
Then here you should put in 1200. Your frequency should be 1. And then here 1300. Enter. Now if you press your NPV, put in 7%, enter, down arrow, and compute. Did that work? What are you putting as your interest rate?
Originally, I was putting 1,500 to 1,300.
Okay, okay. But you're getting the right answer.
Because originally we calculated over the 1,300, so I was trying to read that. I thought that was 5.
Okay, okay. But it's working exactly right now?
Yeah.
Okay.
I had it right the first time, so I went back and I went to my cash flows and I was like, I thought I messed it up because I had it on frequencies and I put the numbers there and then instead of
Okay.
this one.
Now, keep in mind when we're going through these questions and through these problems, your calculator should be coming up with exactly the same answer. Okay? If you're $10 off or $20 off or $50 off, something is not right, because if you've got it set to 4 decimal places, you should be coming up with the exact same answer. So if you're not, let me know. We'll take a look at it and figure out what we need to change to come up with the exact answer. Okay, press your clear button. Well, I'll show you actually. So we're going to press our clear button here to go back to zeros. Then we're going to use the format key, which is right above the decimal. So I'm going to press my second key and the decimal. Now, if mine's set to 4, if yours is not, you want to press the number 4 and then press the enter key. And again, keep in mind, when I say the enter key, I'm not talking about the equals key. A lot of times people want to press this, okay? I'm talking about the enter button. And now if you press your clear button in the bottom left-hand corner, it should say 0.0000. All right, good questions. Okay, number 15, the rate of interest actually paid or earned, also called the annual percentage rate, is this is actually not a good question. It would be a better question if this were taken out, this also called the APR, okay? Because you're going to get some conflicting results. So let's just read this question as the rate of interest actually paid or earned is the blank interest rate. So that would be the effective rate. Now, the contractual rate of interest that doesn't take into account the effects of compounding, that is called the nominal rate of interest. And you need to know the difference between those two definitions. Then number 16 is a loan payment calculation. It says Betty borrows $50,000 at 10% annually compounded interest to be repaid in 4 equal annual installments. The actual end of year loan payment is. So again, your calculator is set to 1 payment per year. Your present value is $50,000. That's how much you're borrowing. You're going to pay it back in 4 payments. Your interest rate is 10%, and you want to compute, in this case, the payment amount. And so the payment is going to be $15,773.54 per year for 4 years. And I can work through that really quickly if you want me to. Okay, so 50,000 present value, 4 in 10 interest per year. Compute the payment. Right answers? All right, so any questions about the first 16 questions that are from chapter 5 before we move on very quickly to chapter 8 questions? Okay. Number 17, if a person's required return does not change when risk increases, that person is said to be, that's supposed to be A, B, C, D, so it should be answer B, risk indifferent. Okay, now that was part, and keep in mind, when you go to your integrity recordings, one of the recordings, we didn't have class that day, but I posted the first part of chapter 8. Okay, so be sure to go back, take a look at that. If you go to your Canvas homepage, which, okay, so we're here. So if you go to your integrity recordings, what you're going to see, once it brings it up, you're going to see some information here. So this is chapter 8, okay? So chapter 8, part 2 of 3, chapter 8, part 3 of 3, and if you go to additional content, this is chapter 8, part 1 of 3. So the question that we just covered is in this part, okay, this lecture. So be sure to go back and take a look at this under the additional content area. All right. Okay. Number 18, if a person's required return decreases with an increase in risk, that person is said to be, the answer is risk seeking. Now there are 3 different risk behaviors that we talked about in class, or that I talked about in the recording. That is risk averse. That means if you're risk averse, you want to be paid for taking additional risk. Risk indifferent means you don't necessarily require a higher return for taking more risk. And risk seeking means if you take more risk, you would actually be happy with a lower rate of return. Most people don't fall into the last 2. Most people fall into the risk averse category, which means you don't mind taking more risk, but you want to be paid for taking that risk. 19, blank is the chance of loss, the variability of returns associated with a given asset. The answer is C, risk. Number 20, this is a percentage rate of return problem that's also covered in the part 1 recording. Last year, Mike bought 100 shares of Dallas Corporation stock for $53 per share. During the year, received dividends of $1.45 per share. The stock is currently selling for $60 per share. What rate of return did he earn over the year? So your formula for this, which will be given to you, is the newest value, okay, or the ending value minus the beginning value. So at the end of the year, the stock is worth 60. At the beginning, it's worth 53. And then we're going to add any cash flow received during the year, which in this case was $1.45 per share, divided by the beginning price. So we simply take 60 minus 53, which is 7, plus $1.45, which is $8.45, divided by 53. That comes up to 0.1594, or 15.94% positive annual return. Is everybody good with that calculation? See where the number's coming from? If you happen to see this exact problem again, you could work it on the test. This exact problem with these exact numbers, you could work it on the test. Yes, all right, good. All right, the blank measures the dispersion around the expected value. That is the standard deviation, one of your favorite topics to study. Number 22, the blank is a measure of relative dispersion. Now, keep in mind, we talked about the coefficient of variation. We said it's a measure of relative dispersion because it's useful for comparing the risk of assets with different expected returns. Okay? So, the standard deviation is an absolute measure. Coefficient of variation, relative measure. 23, since for a given increase in risk, most managers require an increase in returns. They are, which we just discussed, risk averse. All right, the expected value, standard deviation of return, and coefficient of variation for asset A is, now I haven't worked this out, but would you like for me to work through this really quickly? All right, I was afraid you were going to say that. Okay. All right, so let's see, 25 and 5. Well, I've got them written down here. This will be helpful to me for the number. Okay. Okay, so the standard deviation. First of all, we need the expected return. So we're going to call this R bar. And this is simply going to be the probability times the return. So this would be 0.25 times 0.05 plus 0.55 times 0.10 plus 0.20 times 0.13. And if you would, I'll let somebody, if you would kind of go through the math there and see what that answer should. It should be 0.0935, but I want to make sure that's correct. .0935. Is that right? Okay. So I am getting confirmation that that is right. So we'll say 0.0935, or the expected return is 9.35%. But we're going to keep it as a decimal so we can calculate our next item, which is, what's it asking for? Standard deviation. All right, so standard deviation for asset A is equal to, now, if you take a look at the formula, it says the return associated with an outcome minus the expected return squared times the probability of that return occurring. So we've got 3 different possibilities. We're going to have 3 of those calculations. So with this one, it's going to be the return of 0.05 minus the expected return of 9.35. See, let me add a, okay, there we go, times the probability of 0.25 plus, got too many brackets going on here, okay. The next one is a return of 10%, so 0.10 minus 0.0935 squared times a probability of 0.55 plus the return of 13%. The 5, by the way, squared times a probability of 20%. And remember, all of this for the standard deviation is under the radical. Okay, I realize that's messy, but now again, the order of your calculations are important here. So we would take 0.05 minus 0.0935, which is going to give us a negative number, but once we square it, it will be a positive number, and then times 0.25, whatever it might be. It's going to be a really small number. And then the second one is probably, and just looking at the numbers, is probably going to be 0, although I haven't worked it out here. That'd be 0.0065 squared times 0.55. It's going to be a really small number, whatever it is. And if it goes out past 4 decimals, you don't have to worry about it. And so once you go through all of this, and once you do all your math, and then find the square root of the solution, I'm hoping you're going to come up with 0.0276. So is anybody fast enough to have calculated those right? Okay. And then finally, it asks for the coefficient of variation. So the coefficient of variation. By the way, what's the formula for the coefficient of variation? Standard deviation divided by the expected return. Okay. So in this case, that's going to be the 0.0276 divided by 0.0935. And I'm guessing that is going to equal 0.3. Is that right? Okay. So if you happen to see a problem such as this on the test, you are good to go with expected return, standard deviation, coefficient of variation. Everybody have this written down? This is all number 26. That's a lot of work for 2 points, isn't it? Yeah. Or it could be broken down into, you know, part A is expected return, part B is. The problem is, if you miss the first one, you're going to miss the next 2. Okay? All right. So let's. Okay, this is all number 24. All right, number 25, the blank portfolio maximizes return for a given level of risk or minimizes risk for a given level of return. We said that is the efficient portfolio. So we're trying to put together a combination of investments that basically gives us the most for taking the least risk, or just the opposite. Number 26, I'm not going to read through all of that, but it's going to be perfectly positively correlated is plus 1.0, and perfectly negative correlation is negative 1.0. Number 27, combining negatively correlated assets. Having the same expected return result in a portfolio with a blank level of expected return and a blank level of risk. So the same level of expected return and a lower level of risk. All right, so these calculations are related to number 28. It says that an investment advisor has recommended a $50,000 portfolio. It contains 3 investments, R, J, and K. You're going to invest $25,000 in R and earn 12%, 10,000 in J and expect to earn 18%, and 15,000 in K and expect to return 8%. What is the expected return of the portfolio? So again, this is just a weighted average. If you're not given percentages, you're given the formula on your formula sheet. How do you calculate the percentage weight of an asset? The dollar value of the asset divided by the total value of the portfolio. So for R, that would be 25,000 divided by 50, which is 50%, 0.5. For J, 2,000 divided by 50, which is 20%. And for K, 15,000 divided by 50, which is 30%. So the formula, which again, you're also given this, is going to be the weight times the return for each asset. So this is going to be the 50% weight of R times the return of R plus the 20% weight of J times the return, 18% return of J, plus the 30% weight of K times the return of K. Run through the math, you should come up with 12% even. All right, so everybody see where the numbers are coming from here? All right, let's see. All right, so here's the numbers, here's the question. Number 29, the correlation of returns between asset A and B can be characterized as, so if we go back and take a look, asset A and asset B, is asset A is increasing in value, asset B is decreasing in value. So we could say that that is perfectly negatively correlated. And if the question was, what is the relationship between asset A and asset C? Since they move exactly together with the same string, we would say that that would be perfect positive correlation. Number 30, systematic risk is also referred to as non-diversifiable risk. Number 31, the purpose of adding an asset with a negative or low positive beta, and I guess it should say to your portfolio, is to B, reduce risk. Number 32, the beta of the market is always 1.0. We said if a stock has a beta of higher than 1, it's considered riskier than the market. Lower than 1 is considered less risky than the market. And finally, 33 is a capital asset pricing model question. Asset P has a beta of 0.9. The risk-free rate of return is 8%. The return on the market portfolio is 14%. What is the required rate of return? So here is your formula. The required return is equal to the risk-free rate plus the beta times the return of the market minus the risk-free rate. You're given the numbers, you just plug them in. The risk-free rate is 8 plus the beta of 0.9 times the return of the market of 14 minus the risk-free rate of 8. So if we work through this, 14 minus 8 is 6 times 0.9 is 5.4 plus 8 means we have a required return of 13.4%, which matches answer A. All right, these are very good practice problems and should give you a pretty good idea of how you should prepare for the test. Now be sure to take a look at the study guide that's on Canvas. Okay, just 2 chapters. Go back to 30 and 31. If you have any questions, you feel free to email me. I mean, I'm going to be traveling, so I'm not sure when I can get back to you, but I will try to answer your emails. Keep in mind, I will not be around tomorrow during office hours, but I'll try to get to your emails before the test. All right, so everybody study hard. Thursday's your test. Good luck on that.
Do you have a class before this class for finance? Because I had to work Friday, and